ladder.
Yes.
Good.
Please. Just get my mind.
Okay. The top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? Okay. We haven't really had to do it yet, but picture time?
Mm-hmm.
The others haven't really needed a picture, have they?
This one. Picture.
This one needs a picture, okay? You need to be able to see this. Okay, so that is my wall. Okay? Here is my ladder. Okay? What do we know about the ladder?
It's sliding.
Okay. It's 25 foot long. And of course that makes this the ground, yes? Okay, so we've got the wall, we've got our 25-foot long ladder, and we have the ground. Okay.
Why is it so hot in here today? It was freezing yesterday.
It's cold.
I'm sweating right now.
I'm comfortable / cold.
I hate
Okay, now, the top of a 25-foot ladder is sliding down the wall. Okay, so that's going to slide down the wall. I need to throw some variables in here to make this happen. Now, as I throw a variable in here, I'm going to go with the fact that this is a vertical distance that's going to be changing. So I'm going to use y for this side. Okay. Now, as the ladder slides down the wall, this side is going to go farther out, yes? That's a horizontal distance, so I'm going to call this x, okay? And then when the top of the ladder is 7 feet from the ground. Now, notice that right there is part of the question, isn't it? So don't label anything 7 on your paper or on your picture, okay? Because that's part of the when the top of the ladder is 7 feet from the ground. So that's one of those when we get to the end, we're going to plug 7 in at the very end, okay? What is the rate of change of the distance between the bottom of the ladder and the wall? Okay, so top of a 20-foot ladder, sliding down a vertical wall at a constant rate of 3 feet per minute. I'm not going to say DH. I'm going to use a variable I already have.
DY.
If this ladder is sliding down the wall, then the y distance is changing. Because y represents the distance from the top of the ladder to the wall. Does that make sense? Or top of the ladder to the floor. Are we there? So that means in my given, I can say that dy dt, as it sliding down a vertical wall, so sliding the vertical distance being y, so dy dt is 3 feet per minute. Okay? Huh? Yes. Valid point. Okay, so negative 3 feet per minute. Now, when the top of the ladder is 7 feet from the ground, I'm not putting 7 on my picture, remember, but what is that 7 representing?
Y.
That's going to be a y value, right? So when we're being told what to find here, we're going to be evaluating it when y is 7. Does that make sense? We just haven't talked about what it is that we are finding. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall?
So it's dy dt. You already guessed that.
No?
dx
dx dt. Because the rate of change between the bottom of the ladder and the wall is going to be the change the change of x. So we're going to be trying to find dx dt. Okay? Now, we have the given. We know what we're trying to find. If you recall, our no is kind of an equation. What connects all this? What relationship do x and y have?
Oh, that's stupid. Never mind.
What shape do you see here?
Triangle.
Triangle. What type of triangle?
Right triangle.
A right triangle. What do we know about a right triangle?
A squared is supposed to be squared equals c squared. That's
The guy
actually
who's
right.
Do we not just have that back here?
It was one of the ones we differentiated on the first day, and I even said it would be a slider problem reference.
Oh, yeah.
Okay? So now, instead of a squared and b squared, what am I going to say?
X squared and y squared.
X squared and y squared. And instead of c squared,
25.
it's always 25, isn't it? I don't need to throw another variable in because the length of the ladder is 25, so 25 squared. Okay? Let's do it. Okay? What's 25?
The length of the ladder.
Oh, no,
No,
give me a
what
second.
is-
As in, what's the number?
Mhm.
I don't know. It's not going to matter.
Oh, okay, cool.
I mean, fair enough. It's 625 if you really want it, but in all honesty, it's not going to matter. Because what was the first thing I do with this equation?
Differentiate.
We're going to differentiate. And 25 squared, no matter what it is a
0.
constant, and the derivative of a constant is 0. Okay, so derivative of x squared,
I will.
2x dx dt plus y dt.
Equals
Realize the derivative of 25 squared is not 2 times 25 and all that business, right?
It's just 0.
It's just 0. Okay. Okay, now, we can do this one of two ways. Curious, how did I do this in my notes? Okay. We can do this one of two ways. I've seen it taught both ways. So what we did on several of the ones we did yesterday, we just went ahead and plugged in numbers here, right? And so we can go ahead and plug in numbers. And then once you get all your numbers plugged in, you'll have to solve for dx dt. The other option is to go ahead and solve this for dx dt and then plug in numbers. I'm trying to think. The ones we had yesterday were kind of already, well, one of them was already solved, wasn't it? The other one was not. So I don't know. Do you? Let me show you the solving. Okay. So what am I going to be trying to solve or find? Dx dt. So if I try and isolate dx dt, what's that mean I'm going to do?
Subtract.
Subtract the 2y term over. So I'm going to have 2x dx dt equal to negative 2y dy dt. How do I solve for dx dt?
Divide by
2x.
Divide by 2x. So then dx dt, and I'm going to write this as negative 2y divided by 2x, and the dy dt, you can just stay beside it. There's a cleanup we could do here.
2's.
The 2's can cancel. So this equation can really clean up and be dx dt is the negative of y over x times dy dt. And so then at this point, your option is you just plug all your values in, right?
Yeah.
Okay. So dx dt is equal to the negative of, what's y?
7.
This is the time to use 7. Divided by, what's x?
3.
No,
Oh,
you don't
just
know.
kidding. I don't know.
pause that thought. I'm going to leave it blank. What's dy dt?
-3.
Okay. We need a value for x.
We plug it in to the equation up there, right? That one.
At
That's what I
this
wanted to do
point,
at the beginning, I was like, that's-
okay, but we can't do it at the
I know.
beginning. Okay, so at this point, the ladder is always 7. We are trying to talk about when the ladder is 7 feet from the ground. So when y is 7, does x have a definite distance? It does. So we need to do x squared plus 7 squared equals 25 squared. So 625 minus 49 is 576. The square root of 576 is 24.
Thanks. That's so.
I forgot about that. Okay, sorry. Fair enough. You did need it at some point. Now, here's the deal. We didn't plug 7 in at the beginning, right? So we weren't going to use the 24 at the beginning. I didn't want to have us find it too soon. Okay. You got an answer?
7/8.
He says 7/8. Okay. Yeah, I'm there. Sorry, I'm distracted by a phone call. I wanted to answer. Okay. Yeah. I would cancel there. So, yep.
And the negative. Cancel.
Yep. Negative and negative is positive. 7/8 what?
Feet per minute.
Minutes.
Feet
I
per
saw
whatever
a
unit.
minute After a second.
I don't blame you. It's weird to go by minute.
Thank
Okay.
you.
It's feet per whatever time unit because it's change in x. X is a length, so that's going to be feet over change in time, which in this case was distance. Okay,
The ship was sailing.
let's go sail our ship. At noon,
Oh.
almost noon, Ship A is 150 kilometers east of Ship B. Ship A is sailing west at 35 kilometers per hour, and Ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.?
I can't picture.
So, again, we need a
Picture.
picture.
I can't draw.
And the north
So just do little circles.
My ships are going to be points.
I'm gonna draw shit.
You draw all the ships you want.
I can't draw one.
Natalie,
I'm not drawing a ship.
Focus.
Okay? Natalie will be drawing lots of ships because she draws during math notes, right? So, okay.
And she gets to
Now.
see on things.
Here's the deal. We have to know our directions, yes?
West.
Holy shit.
That way. Never eat soggy waffles.
I say sour waffle.
Okay, that's boring. Sour wheat.
I say shredded wheats, so
If it's a soggy waffle, then
I'm from a different generation, okay?
That's fair.
You
I
gotta
just know my direction.
You gotta eat your.
That's an option too.
never eat
Okay.
You gotta eat
So,
Wheaties. Well,
at noon,
champion.
Ship A is east of Ship B. So if Ship A and Ship B are east of each other, they're on a
Eggs.
horizontal line, yes? Okay. Which one was? Ship A is east of Ship B. So there's my Ship A, there's my Ship B. Good enough?
Good enough.
Ship A is sailing west. So, Ship A is sailing west at 35 kilometers per hour. We'll come back and talk about what that what that label will be here in a little bit. Ship B is sailing where?
Eat
North.
Duh, Mama.
Okay. Ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Okay, guys.
4 hours.
4 hours later, how are we going to connect their differences? A will have moved this way. B will have moved this way. They're going to be connected by
A dotted line. Ish.
another line. Okay? It doesn't have to be a dotted line, but that's kind of the way I, look at it.
So another exclamation.
Okay. So, with this in mind, okay, got to think all this through because we don't have our nicety information like we did last time. Okay, so at noon, ship A is 150 kilometers east of ship B. So right now, this distance is 150 kilometers, yes? However, is it staying 150 kilometers? No. What's it doing? It's decreasing by what?
35.
35.
Okay.
Oh, my sail should be the other way.
Okay. It's decreasing by I'm going to use a variable here because we don't, I mean, it's, okay, that's a rate, but we need the variable. And so
35.
I'm just saying X. Okay. So I'm going to use 150 minus X. Is this what I did? Yeah. I'm going to, well, wait a minute. What did I do here? Yeah. Okay. Sorry. 150X for this part because it's changing, but we know it starts at 150. B. He's moving north. I'm going to call that distance Y. I don't have anything about specifically like a starting amount or anything. Okay? And then how fast is the distance between the ships changing at 4 p.m.? That means what are we going to be trying to find?
The hypotenuse.
Well, in relation to the hypotenuse. So I'm going to use Z. Okay. Let's see what we know. Okay, at noon, ship A is 150 kilometers east of ship B. Ship A is sailing west at 35 kilometers per hour. What information is that?
Given.
It's given, and it's the change in what? This distance, which really is in reference to, we're not going to say 150 minus X, but in reference to X, okay, because this is our X difference. In other words, the distance of X is changing. So we're going to say that dx dt is, what was it?
35 kilometers per hour.
35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. What is that?
Another D1.
Right, it's your change in Y. So dy dt is 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? What is that we're trying to find? The change in the distance between the ships, which is going to be the change in,
dx dt.
not dx, dz dt.
Dang it, that's what I meant to say.
I feel that.
So we're going to be finding dz dt. And I'm just going to say at when?
4.
At 4 p.m., yes?
My brain's not
Okay, do we have everything? Oh, well, we haven't filled in the no yet, have we? What connects all this?
X squared. That's y squared.
equals.
Right triangle again, Pythagorean theorem again, yes?
Yep.
And you can generally, I mean, for the no, if you want, you can just think about the idea it's x squared plus y squared equals z squared. But what are we using for that length of x? We're going to actually use the 150 minus x when we work with it here in a moment. Okay? So, instead of x squared, I'm writing
2x.
150 minus X.
150 minus x, quantity squared, plus y squared equals z squared. Which way did I do this? I did do it that way. Okay. My brain was going back and forth between foiling that first piece out and then differentiating, or differentiating and not FOILing. And as I look at my notes, I actually differentiated without FOILing. Okay, so how do you do the derivative of something to a power?
Pull the power up front.
Okay, so pull the power out front, 2 times 150 minus x.
DFT
Power becomes
1.
1. Hold on. Times
The derivative of the inside.
derivative of the inside. What's the derivative of 150 minus x?
DXT.
Negative 1. And then also times
Yeah.
dx dt.
Yay.
Plus derivative of y squared.
2 YD.
2y dy dt equals derivative of z squared.
0. Oh my god.
2z dz dt. I do not have a number this time. That would be a problem if it's a 0, because I'm supposed to be trying to find dz dt. So that would be a problem.
This is a lot.
That's definitely not gonna be added.
Okay. I don't want to divide everything by 2z yet. I think that would give me I'm trying to think, would that, I feel like that'd give me a disaster right now.
Yeah.
I think I waited and did it at the end on this one. But now, I don't know, do you guys see it? What does every term have in common?
2.
2. Can we divide the 2 out
Yeah.
and it just be gone? Because this is an equation, we can divide 2 out of each side, yes? So if you divide 2 out of every term, it kind of cleans things up a little bit. Now, on this first term, we have the 150 minus x to the first, which is just 150 minus x, times this negative 1.
X minus 150.
Can I go ahead and distribute that in so it's not quite, we don't have so much extra stuff hanging out? Not saying you'd have to distribute. I'm pretty sure yeah. Okay, so I was going to write it as negative 150 plus x, but Kylie threw out x minus 150, so I'm going for it. Times dx dt plus y dy dt equals z dz dt. And here's the deal. Could you go ahead and just write one big old divide by z? You can. I think it's just going to look a lot messier as we work to fill in numbers here. Okay? Now, with that in mind, we have to fill in everything except dz dt.
We don't have.
Don't have an extra y though.
Okay, so that's what I'm trying to look for here.
But we don't have that.
So we have dx dt, we have dy dt.
Yep.
We need to talk about x, y, and z, don't we? Okay, so this is where the 4 hours comes into play. Let's talk about A, ship A. Okay. Ship A. In 4 hours, what will ship A have done?
Going up 140.
Why 140?
35 times 4.
Okay. 35 miles per hour, or excuse me, kilometers per hour.
And it's been
And in 4 hours means ship A, which, and here's the deal, I'm trying to find X, right?
Mhm.
So this is going to be my X value because A is traveling X. Okay. And so that's going to be the 4 hours times the 35 kilometers per hour, which is just 140 kilometers. Because Mario had already done the math there. Okay, so what we have right now, X, I'm going to plug in 140 for X here in a little bit. Okay? Let's talk about ship B. What does ship B determine?
1.
Ship B is going to determine Y. What is ship B going to be doing in 4 hours?
Traveling 100.
Okay. 4 hours times 25 kilometers per hour means that ship B will have gone 100 kilometers. Are you following the logic here? Now, I also need a Z.
These are these.
Put them in. Plug them in.
This is Pythagorean theorem. Okay, so this is the, going back to the 150 minus x quantity squared plus y squared equals z squared. Okay, so going back here and plugging in. So 150 minus 140 quantity squared plus 100 squared equals z squared. Ten squared plus 100 squared. So it's going to be 100 plus 10,000. So as he said, 10,100. What is z going to be equal to then?
The square root of that.
The square root of that. Which in my notes, I just have it as the square root of that. I think what I did is I waited till later to plug it into my calculator. Because
Does it
here's
have a perfect square?
it does not. I don't think it does. Otherwise, I would think I would have written it down. Okay. And here's the deal, guys. If I go ahead and plug it in now, then I get a decimal, and we have to keep lots of decimal places. Much easier to just write a square root symbol. Okay? So, do we have all the information we need now?
Yeah.
I think we do. Okay. Let's go back and plug in. X minus 150.
140 minus 150.
So I'm going to have 140 minus 150 dx dt
35.
35 plus y
100 times 25.
times 25
10,100 square root. Square root of that. dz dt times dz dt.
I'm there. I'm there with what she said. Okay. 140 minus 150 is negative 10. Negative 10 times 35,
Negative 350.
negative 350.
350.
100 times 25 is 2,500. Square root of that business times dz dt. Negative 350 plus 2,500.
A number.
22.
2150.
21. Dang it.
And obviously you may skip some of these steps. Okay. What do we know about dz dt? Actually, I just left the answer with the square root, I guess. Well, I left it in two different ways. So one option to leave dz dt is 2150 divided by square root of 10,100. What would be your label?
Kilometers per hour.
Kilometers per hour. And this is at 4 p.m. If you got a decimal, anyone do the decimal?
I left my calculator on there.
I have written down it's 21.393. Okay. Moving on.
I just yawned. Oh no.
Okay.
My gosh, she pushed those things on.
6. A right circular cylinder is changing shape. The radius is decreasing at a rate of 2 inches per second, while its height is increasing at a rate of 5 inches per second. When the radius is 4 inches, the height is 6 inches. How fast is the volume changing? And notice what information she provided for
This is
us.
the volume.
Volume of a cylinder.
Cylinder.
Okay. What is a cylinder?
The thing. A tube.
A Pringles tube.
Yeah.
Yeah.
But still,
A Pringles can.
Or PVC bubble cube.
Tube.
Oh.
Did you guys hear?
I think of like a soup can when I think cylinder,
That's
but
kind of my thought too, but
soup's
you know, Pringles can, tube, whatever. You say tube, now I'm thinking like a paper towel roll or a toilet paper roll, you know. Whatever, we got a cylinder.
legit.
Okay, it's changing shape. We're going to have to talk about the radius. You know what the radius is, yes?
2.
half the diameter.
And we're going to have to talk about the
Height.
height. Okay? So, really, the picture, that's about the most picture we need. There's not really information we need to fill on the picture, in my opinion. So, the radius is decreasing at a rate of 2 inches per second. What's that?
Yep. Or
The RDT
2 inches.
is what?
Negative 2 inches.
Negative 2 inches per second. While its height is increasing at a rate of 5 inches per second. So DHDT is
Equals 5 inches per second.
It's 5 inches per second. When the radius is 4 inches and the height is 6 inches, how fast is the volume changing? What are we trying to find? How fast is the volume changing? So dVdt when
Height is 6 and radius is 4. Did I?
Nope, that was me.
Sorry, I could have looked on the
No, I just wrote wrong. Okay, so we're trying to find dVdt when the radius is 4 inches and the height is 6 inches. I don't know if that's a legitimate way to write that or not, but,
I think it looks accurate.
you know,
Works for us.
I don't know, maybe she had it
Mrs.
written in her notes.
Sargent
Who
says
knows?
it's right, so it's right.
Okay,
Duh.
what's our no?
The derivative of
So I sent it.
Well, our no is the given formula, right? Okay, we're talking about volume of a cylinder, which, guys, remember volume? Volume for any object that is the same on both ends is the area of the base times the height of the object.
Oh.
The area of the base is a circle, pi r squared, times the height of the object. If it's a pyramid or cone type shape, you just put a 1/3 in front of it. Okay? But, okay. V equals
Pi.
pi r squared h. So, let's differentiate.
Equals pi 2 pi r drd.
I feel like I.
And times,
Times dHdt.
no, just h. So what are we supposed to be doing here?
Oh,
I'm not sure if Hannah's doing this or not.
sorry.
This is a product rule, yes?
Yes. Times h plus.
Okay.
Yes.
Yeah.
So, derivative of pi r squared is going to be
2 pi r
2 pi r
r
dr dt and keep the
times
h. So I wrote that as 2 pi r h dr dt plus,
pi r
now we're going to keep the pi r squared. Derivative of h is just 1 dh dt. Or if you're like Sophie, you just went and copied it from when we did this on day one. But on the flip side, I'm not providing that on a test, right? You have to know how to differentiate that. So that's why I just went ahead and redid it.
I differentiated it.
Okay. Now, find dV/dt.
So we have everything.
We have R and H at the time. We have dr dt, dH dt. I feel like this problem's too easy after the other ones we've done today.
You should plug in.
Okay, plug in.
Plug everything in.
2 pi
Times 4.
times 4 times 6 times negative 2. Did I write mine in a different order than you?
Yes.
Plus pi times 4 squared
Times 5.
times 5.
Oh.
This times 2.
Oh.
6 times 4 is 20.
Not that one.
What's 48 times 2? 96.
Nope.
16 times 5. Oh, wait.
Let me just do it.
What's 8 times 6?
Hmm?
What's 8 times 6?
6 times 8
80.
is
48.
48.
It's 80.
16 times 5, sorry.
6 times 8 is 40. 6 times 4 is 24.
Okay.
Sorry.
4.
Negative 16 pi. I didn't put a label. I was just making sure I had my answer right. Inches cubed per second.
Yay.
Yeah, I kind of did the math and then I checked against my own answer key to make sure that I did the math correctly. Then I came back. Okay. Ready to try 7? I have in my notes last year that I struggled to get through. I don't know that I got through 8. I don't know. I feel like I'm running a little bit ahead this year, but so.
Okay.
I also know this homework's going to take work, guys. Okay? So,
So we
ooh,
can't
I don't have,
not do it tonight.
yeah. I don't have the answer key open yet. Hopefully I remember to get that open later. Okay.
If not, Logan will receive a text message.
Hey, it's there. I just have to publish it. Unlike the last time you texted Logan, I'm like, had to do
Logan
that.
said she's not home right now. And I was like, all right, that's fine.
I told Logan after the fact, I said, had you texted me because I was at school picking Natalie up, the answer key was here in my classroom. That's why I couldn't get it up there that night. So, yeah. Well, this wasn't last night, but this was another night I was here picking Natalie up, and
It was still during football season.
yeah, I think it was probably volleyball for her. So, okay. An inverted cone is leaking water at a rate of 1 cubic centimeter per minute. The cone has a height of 9 centimeters and a diameter of 6 centimeters. Find the rate at which the water level is dropping when h equals 3 centimeters.
So inverted. What is inverted?
What's an inverted cone?
It would be like a V,
Isn't
wouldn't
it
it?
the other way?
It's
Ice cream cone.
Yeah, it's a V.
It's an ice cream cone.
There's my inverted cone, and then an ice cream cone.
Okay.
Okay. Not just any ice cream cone. How's that? Specifically a sugar cone.
Cake cones are sugar.
Waffle cone?
Listen, just because you put
Sugar or waffle?
But it's not waffle because this is unique across the top. Or I mean symmetric across the top. So
I love
so
it.
sugar.
okay. So an inverted cone is leaking water at a rate of 1 cubic centimeter per minute. What is 1 cubic centimeter per minute?
DB.
That is dVdt, right? Cubes is your hint. So 1 cubic centimeter
Wouldn't it be negative?
per minute. Is it negative?
Leaking.
It's leaking.
It is leaking. I am stinking at my negatives today, so good luck. Don't follow my lead, because my negatives are rough today, aren't they?
Yep.
Okay, what else? The cone has a height of 9 centimeters and a diameter of 6 centimeters. Now, did I put this?
So the radius is 3. No, it's not. I don't know if I did that.
Well, okay.
Yeah.
Okay, I think what I just did is I put it over here. So the cone has I just put it over here is what I did. A height of 9 centimeters, a
Diameter of 6.
diameter of 6 centimeters, which what is important there to realize?
Radius is
Yeah, that means we have a radius of 3 centimeters, yes? Okay. We'll come back to that picture here in a moment. We're being asked to find what?
The rate at which the water level is dropping. H is 3.
The rate at which the water level is dropping. What is that? No?
Oh.
DHD.
DHDT. You're trying to find the change in the height. The water level starts at this height and then goes to this height. We're trying to find the change in height. Notice they gave us dVdt, didn't they? So we can't be trying to find dVdt. So we're trying to find dHdt when h equals 3 centimeters. And this, our no is, they gave us 1/3 pi r squared h. Remember earlier I talked about a cylinder with a cone. It has a circular base. So pi r squared times the height. And then since it doesn't have another circle on the other end, it has a point on the other end, it's 1/3 of it. Okay? Okay, now, as we start looking at this, where do I want to put this? Yeah, I've got room there, don't I? Okay. V equals 1/3 pi r squared h. What are we doing? Oh, whoa. Okay. We've got a slight connection we've got to look at here.
DR, DH.
Okay. Do we have any information provided or asked about R? No. Our information specifically relates to V and H. When I differentiate this, is it still going to have R's in it? It is, isn't it? And there's going to be a dr dt. So we can't differentiate this formula. We have to find an equivalent formula that gets rid of R and makes the whole thing in terms of H. Nope, not diameter, because I need everything in terms of V and H. Okay, so this is where we look at similar triangles. Do you see the triangle here?
Yeah.
Okay, so let's pull that big triangle there. And as I pull that big triangle there, what do we know? Ooh, that's a horrible triangle. Oh well. What do we know about this triangle? It has a
Length,
9
height.
on the left leg,
height of 9 and
3 on the top leg.
the radius is 3, which is that top, yes? Now, here's the deal. We're talking about a water level here, aren't we? So somewhere down here, we're going to have a water level. We're going to pull the equivalent triangle, but it's a smaller version of it now. Okay? Where do I want to put this? I didn't set this up very well. So now we've got same type triangle, but it's a smaller version of it, yes? Which means it's proportional. It is a similar triangle. Do we know the height at this point? No. So I'm going to call it H. Do we know the radius at this point?
3.
No.
Not at this point.
Smaller.
It's smaller, right? As this triangle shrunk in all ways. So we're going to use R and H, and we're going to set up, it's similar triangles. You remember setting up proportions?
Yeah.
Yeah.
What are my options? There's a couple different ways we could set up the proportions.
R over 3 equals H over 9.
Okay. Doug just said R over 3 equals H over 9. Anyone else do it differently?
No, because I don't remember.
Okay. And it's the idea. So Doug said R from this triangle matches with 3 from this triangle, just as H from this triangle matches from 9 with this triangle. The other option, what I have set in mind, that's what I thought, is I did R over H. So radius to height compares with
3 over 9.
3 over 9. Now, here's the deal. Either or of these, we need to solve this. So think cross products. if you think cross products, both ways you're going to get what?
9R equals 3H.
9R equals 3H? Whether you set it up my way or Duck's way, right? They're both good. Now, we're wanting to get rid of what variable over there?
R.
R. Solve this for R. If 9R equals 3H,
3H over 9.
R equals 1/3 H.
3H over 9, 3 over 9 reduces to 1/3. R is 1/3 H. Or if you prefer, you could say
H of 3.
H over 3. I don't know which I prefer at this point, but
H over 3.
yeah. Okay, so let's sub. 1/3 and pi are staying. What am I putting in for R?
H over 3.
Either H over 3 or 1/3 H.
Times H.
And don't forget the squared. Are you there? Okay,
We derive
not yet. Let's. Deriving will be a lot nicer if this is cleaned up. Trust me, I'm working in our best interest there. What is H over 3 quantity squared?
H squared over 9.
H squared over 9. Okay. Keep cleaning with me.
H cubed.
Over 9.
Yeah.
Okay, so I heard 1 over 3 times pi become pi over 3. I heard H squared over 9 become, times H become H cubed over 9. How about, which way do I want to take this? We're getting ready to derive this, aren't we? How about we take the 9 out with the pi over 3? Is that what I, yep. If I take that 9 out with the pi over 3, this is pi over
27.
27 times
H cubed.
H cubed. I would much rather derive this than any of these other levels. And I guess I'm starting a new row because, okay,
3 pi over 27 times H dH dt.
Pi over 9.
All right. Well, I hadn't simplified yet.
did you say H squared?
Oh, no.
I wasn't sure if you said it or not. I wrote it,
That part.
but I wasn't sure. Okay, are we there with what happened?
Yes.
Sure.
Pi over 27 stayed out front. The 3, so if you multiply it out front, so she called it 3 pi over 27. Yes, we'll reduce it here in a moment. Subtract 1 from the power. It's H squared times the derivative of H dH dt. If we want to clean this up a little bit, 3 pi over 27 is pi over 9.
H squared.
H squared dH dt. Do I have all information to plug in now?
Yeah.
Yes. So, pi over 9 times,
Why is it H squared and not? Oh, never mind.
okay. What is H?
3.
3.
What is dH dt?
Nothing.
Oh, wait, yeah. Yeah. Yeah, we're missing the 3. There's 3H squared.
No.
No.
DT goes DH.
It's
Oh,
right.
yeah.
Okay. I totally went right along the wrong.
You don't see it went
Okay.
with 3
So
pi
we
over
need
27.
to
That's where the 3
put
went?
Yes, that's where the
DVDT
three-
DH.
Well,
right?
what are we? I wrote dVdt like we were trying to find dVdt. Are we trying to find dVdt?
No,
No,
it's
we already
not
have
DH.
We're trying to find dH dt.
Yeah.
What it should have gone here in place of dVdt.
Negative 1.
H cubed over 9.
But we don't.
I don't need a label right now, but you can. But okay.
I did too.
So this is one where could we have solved this problem originally for dH dt before we plugged stuff in? We could have, but your teacher didn't. So you know,
Oh,
you can
So
you can go either way. Okay. -1. What do you know about pi over 9 times 3 squared?
That's just pi.
It's just pi.
So, okay, this is working out nicely. What is dH dt?
Negative 1 over pi.
-1 divided by pi? Can you leave it like that if you don't have a calculator?
Yeah.
Yep.
Certainly can. What's my label?
Oh.
Centimeters per minute. Centimeters cubed.
It's just a change in height. Height is just a distance, so it's centimeters per minute.
I like when these pop up.
I do have this as negative 0.318 as the calculator answer. Okay? Okay. 8's not happening, is it?
Yeah.
Okay.
Unless you can make it happen.
I can't make it happen. So, you've got homework. Okay? I want you to work on your homework. Okay? Yeah, probably should start tonight. Probably not wait until tomorrow because there's a lot here. Okay? And these are not short problems. Okay? And then, with that in mind, bring back questions tomorrow. I will look through and decide. We may go back yet and do 8. I haven't decided. I need to go back and decide how necessary
Necessary.
it is.
That's a thing.
Gosh. And I will say, 8, if you've looked at 8, is a lamppost, a light pole. That is a typical math problem. Okay?
Oh, their lights are
So, that is a typical math problem. So, we'll see.
And
Okay.
in real life, can you figure out how tall a lamppost is based off of